Hello?
Hey, Ellie.
Hey, Miss Sparks. Is it all working? I've never done this before.
I know. Well, it takes me a minute because I was trying to set up the worksheet. So, um, anyway, well, you look beautiful as always.
Thank you.
You're so sweet. Yeah.
Do you have the pleasure of seeing her?
I have the pleasure of seeing Ellie Jancic today.
I was just wondering with number 4, I just couldn't figure it out, and I sat with it for a while. I just got annoyed, so I thought I'd jump on.
Okay, great. I will start at number 4 then.
Okay.
Wait a minute. I'm going to see if I can. There's something on my screen that's kind of annoying me, and I never can figure out because sometimes it doesn't X and sometimes it doesn't. Are y'all still there?
Yeah.
Okay. All right. I try to get rid of little things that kind of block the screen a little bit so that y'all have more screen to see when I'm writing. All right. So on this one, simplifying the expression, the first thing that you want to do on that top, on the numerator, is I see that I can factor out a 3n out of everything at the top.
Okay.
So that's the first place I'm going to start. So I've got 3n, and then when I factor that out, I would have an n squared minus, and then 3n out of 6n squared is going to be 2n squared. And then a 3n out of that last one is going to be a 1. I would have a 1 left over.
Like just
and then, yes, ma'am.
Okay.
And then on the bottom, I'm going to go ahead and factor it. I'm looking for 2 factors to give me a -3 when they're multiplied that would give me a +2 when I add them. So I know that way one factor is going to be negative, the other factor is going to be positive, and the bigger of the 2 is going to be positive.
So 3.
So it's going to be n plus 3, n minus 1. And so this factors to be 2 factors that give me a +1 that when I add them or combine them that give me a -2 is going to be a -1 and -1.
Okay.
So then I can cancel this one. And so on the top, I have 3n times n minus 1 all over n plus 3. And that's my final answer.
I just it's not clicking with me somehow how you can just change it. Oh, wait, it just foils out. Never mind. That makes sense.
Okay. So you feel pretty good about that one?
Yeah, I do. I'm just a little bit lost. I'm reading through the textbook. Going back to it has been just like a whirlwind kind of.
Okay. All right. So should I is there another particular one that you would like me to go through? Do you want me to just kind of do number 1 and then move on to some of the other ones?
I've checked 1 through 3 on the section, so I'm pretty confident in those. But if we could, I don't know, could we review one from the next section and then kind of just see from there?
Absolutely. Absolutely. Be happy to.
Okay.
And I know Anna jumped on with us. And so, Anna, if there's one in particular that you would like for me to do, please let me know. You can either text it in the text box or.
Okay.
You can even.
Mostly the back page is kind of.
Okay, mostly the back page. Cool. All right. On number 5, once again, whenever it says to find the product or the quotient, I highly recommend just factoring everything first.
Okay.
So on number 5, that one would factor. I can see in the numerator of the first rational expression that I can take a 6 out, and that's going to leave me r minus 2. And then obviously nothing will factor out of r minus 1 here or here. And then this at the bottom is going to be r plus 2, or oops, I wrote plus minus. I was thinking in my head, I've got to figure out factors that multiply together and give me a positive, but when I combine them, give me a negative.
Mm-hmm.
So that's going to be r minus 2 and r minus 1, because negative 2 times negative 1 is positive 2. And when I combine the two, that's going to give me a negative 3. So now I can cancel r minus 1, r minus 2 with r minus 2. And it wouldn't matter which one of these that I did. I could do, let's see.
So can like all the r minus ones cancel? The factoring like always just confuses me, and like all the little rules that can happen.
Well, I'm still going to end with 1 r minus 1 at the bottom, because
Okay.
it's a 1-to-1 ratio. If you don't have another one to cancel it out with, you got to leave it.
So like the two diagonal from each other we can cancel?
Well, you could either do the diagonal or this one, which in this case I did that. But if you had already done the diagonal, then this one would be left. Does that make sense?
Yeah, so it ends with 6r minus 1. Like 6 over r minus 1.
Yes, ma'am. So if I had done the diagonal like that, then this one would be left. So no matter how you look at it, there's going to be 1 on the bottom that's left.
Okay.
Okay?
Yeah.
And then I'm going to do, let's see, I'm trying to think of which one I want to do, because there was one of these that was a little, I think that one, I think this one's okay.
For like
I'm sorry?
6, can nothing be factored out because it's just a 1 in front of the n squared?
Well, this factors because you're looking for what multiplies together to give you a negative 32. That when you combine it, yes. So you know one factor is going to be negative and one factor is going to be positive. So that's going to be n, and the larger of the two is going to be the positive one.
So like
because you've got that. So n plus 8, n minus 4. And so what you'll notice here then, remember on our worksheet where it was if there was an n minus 4 and a 4 minus n, remember that's a special case, and that factors to be just a negative 1.
Okay.
So then you have, for your final answer, a negative 1 times n plus 8 with an n minus 10 on the bottom.
Okay.
And then you could then do this as negative n, or the opposite of n, minus 8 over n minus 10. But I don't care if you leave it like that. If it was like that on the test, I'd be fine, because most of the rest of these we're all leaving in factored form anyway. Yeah. So really not that big of a deal.
Okay.
And number 7 kind of has some of the similar things, because when you factor this, you're going to end with a negative 1, I think, if I'm not mistaken. But it would look like.
It looks like that, yeah.
You can factor out a 7x squared. And that's going to leave you at x minus 5.
Yes.
Right?
And then it becomes the negative 1 thing again.
Yes, ma'am.
Okay.
Becomes that negative 1 thing. So you would have this canceled with that for a negative 1. And then this canceled with the 7. So then you just are left with 1 times negative 1 times x squared on the top, because all of this would be a 1 on the bottom. So it's literally negative x squared.
Got it. Okay, thank you.
How about you, Anna? Is this making sense to you on these? You're good? You feel pretty good about these?
Yes, ma'am.
And then remember on this number 8, you would flip that second one. You want me to do a division one?
No, I think I got it.
How about you, Anna?
I'm good.
Okay. All right, then I'm going to go ahead and move to the sum and difference. Okay, so on these, the first thing that you want to do is factor the denominator if you need to, if they are not matching. But you'll notice on numbers 11 and 12, the denominators are matching. This is pretty much the same. So then all you have to do is combine like terms in the numerators. So there's only one 4R, so that's going to give us 4R. And then we've got 6 minus 1, which is going to give us a 5, all over 10R squared plus 5R minus 5. And that's your final answer.
Got it.
So you don't
Same
have to
thing.
factor out the bottom?
No, ma'am, you do not. Great question, though, Anna. You could if you wanted. I mean, you definitely could if you wanted to, just to be sure that nothing factored from the top, but you really don't have to.
Okay.
Because you definitely could factor a 5 out of that, couldn't you?
Mm-hmm.
But I don't think you can do anything else because it'd be 2R squared plus 1. I don't think you can. I mean, yeah, I guess you could factor it all the way down, but I don't think anything comes out. So I don't think it feel like it's really worth it.
Yeah.
On this one, however, so I'm glad that you asked the question, because on number 12, if you combine like terms, the best thing to remind you guys is when there's that minus in the middle, that's going to be n minus 3 minus n minus 3 all over. And then I'd go ahead and factor that one. That comes out to be 9 times n plus 4. But on the top, then that's the n minus n, so they cancel out. But I've got a -3 and a -3. So that's going to be a -6 over 9 times n plus 4. And 3 will go into both of those. So that's going to end up being -2 over 3 times n plus 4.
Why did you change the denominators even though they're still the same?
The reason why I did that was because once I factored, because I could kind of tell that I was going to be able to factor something out of my final answer. So you see what I'm saying? Because I was able to factor that -6 and the 9 down to a -2/3.
Okay.
That's why I said it's probably a good idea to go ahead. Like this one, we probably should have just done this. Oops. Didn't mean to do that. I'm thinking of what it is. So on this one, then you could probably factor that even further down, but nothing is really going to cancel out. You see what I'm saying? But you wouldn't really know that unless you factored it.
Okay.
And I caution you, I know there's a 5 here and there's a 5 there, but this is a term. So those don't really cancel out.
Yeah.
Okay.
And you could probably, I think you can factor that one even further down. But the reason why you factor in cases like that, even though the denominator is the same, the reason why you factor is like in this case with the -6 over the 9, you want to look for things that you can either A, reduce or cancel out. So that's the reason why you're doing that.
Okay.
I'm going to write this answer back up here and give myself some more room to work on number 14 when we get there.
Mrs. Sparks, do you think you could go back and do number 10?
Absolutely. Anything that y'all ask, I'm happy to help out. On the first one, obviously you're going to keep the first. I'm going to write over here. Actually, you know what I'm going to do? I'm going to go ahead and factor while I'm doing that because I don't have a lot of room to write. Is that okay with everybody?
Yeah.
I'm
Yes,
looking for
ma'am.
two factors that multiply together to give me a negative 56 that when I combine them give me a minus r. So that means one's going to be positive, one's going to be negative, and the larger of the two is going to be negative. So I see 8 and 7 with the 8 being the negative all over. And then for a negative 8, I'm going to do r plus 4, r minus 2. And then over here, so I keep the first, and then I change my sign to multiplication and flip this to the reciprocal. And lo and behold, well, they're almost the same, aren't they? This is going to be one of those scenarios where we have 56 plus r minus r squared. So what I'm going to do is actually, when you turn this around, like if I were to rewrite this, it would be negative r squared, okay, plus r plus 56. Okay, does everybody see that? How I did that? Writing it in standard form, but then I've got that negative out front. So here I'm going to go -1 to pull that negative off the front, and that literally flips all of my signs within that term. Does that make sense to everybody?
Yes.
Any questions
Yes.
about that? Okay. All right, so then this actually looks exactly like that, which then factors to r minus 8, r plus 7. Okay? And now what I can do is cancel my like terms, r minus 8, r plus 7, like that. So then I have a -1 on the bottom, but I want to reiterate that a -1, it really wouldn't matter whether it's top or bottom because I have a positive on the top and a negative on the bottom here. But it doesn't make any difference because a negative divided by a positive is still a negative, or a positive divided by a negative is still a negative. So I'm going to end with a -5, even if I put it out front as the leading, 5 over r plus 4, because this is all that's remaining, r minus 2 as my final answer for that one. Does that make sense to everyone? Is there any specific questions about the steps?
I'm sorry, I completely missed like where the -1 came from in the like right side of the problem when you flipped it. Like, is that just what you do when you flip it? Like you add a -1?
See how it's written at the top in the numerator? Okay.
Yeah.
56 plus r minus r squared. Do you see how similar that is to the numerator over here?
Yeah, I do.
Okay. Well, all I did here, this
Oh, I'm sorry.
is
You multiplied
actually equal to this, but it's written in standard form. So in order to get my leading term to be a positive, I factored out a -1, which is down here, and I rewrote everything. So this became positive, this became negative, and this became negative. And then my -1 is out front.
Okay.
Does that make sense?
Yeah.
Okay. All right. I'm going to move on to number 13. Is that okay with everybody? Or is there another one that someone would like me to do prior to 13? Okay. All right, so number 13. We have to get a common denominator because the denominators are not the same in these two cases. So in this first one, we can see that we need to multiply the top and the bottom by n minus 1. And on this second one, we need to multiply the top and the bottom by n plus 5. Well, now we'll have one big common denominator. And up here, we're going to distribute that 3 to everything inside the parentheses. So we'll have 3 times n, which is 3n, and 3 times negative 1, which is negative 3. Now, this is like distributing a negative 5 to everything inside the parentheses. So negative 5 times n is negative 5n, and negative 5 times 5 is negative 25. So now we'll combine like terms. We have 3n minus 5n, so that's going to be negative 2n. And then we have negative 3 combined with a negative 25, that's going to be negative 28. All over n plus 5, n minus 1. And I could factor a negative 2 out of that. But it really doesn't change anything because I can't factor anything out. So if you would have left it at negative 2n minus 28, that's fine. But if you would have factored the 2 out and you give me negative 2n plus 14, I'm fine with that as well.
Okay.
Because at least it's showing me or Miss Wynn that you're trying to look for things that can factor out. Does that make sense?
Yes, ma'am.
Okay. I don't have a lot of room to leave all of this stuff, so because I need to make room. So I'm going to erase this and stick the answer back over there. I hope I'm not erasing something too quickly. Somebody needs that work. So or you could have left it like this because nothing canceled anyway. Either way is fine. All right, on number 14, we're going to have to multiply each side like the 6p on the top. We'll multiply that by p plus 6 over p plus 6 because that's what's missing in order for it to have a common denominator. And over on this side, we're going to multiply the top and the bottom by p plus 2 because that's what's missing for this second rational expression to have a common denominator in order to combine. So I'll write this all as one big fraction. And I'm going to distribute 6p to both the p and the plus 6. So that's going to give me 6p squared plus 36p. And then this is going to be distributing a negative 6p to p plus 2. So negative 6p times p is 6p, negative 6p squared, and negative 6p plus times a plus 2 is negative 12p. So now I'm going to combine like terms. So the 6p squared cancels the negative 6p squared. And I'm going to combine 36p with a negative 12p. And that's going to give me 24p over, actually, I'm going to write my answer up here. 24p over p plus 2, p plus 6.
And does like a 2 need to be factored out of that, or can it be left as it is?
It can just be left as is.
Okay.
Because you really can't cancel anything.
Mm-hmm.
So you're fine.
Got it.
All right. On this last one, we're going to multiply this first rational expression by a 5 in order to get a common denominator. And the second part, we're going to multiply the top and the bottom by a minus 4. So if I distribute that 5 to both the a and the 1, that's going to be 5a plus 5 plus, and then distribute the 3a to the a minus 4. That's going to give me 3a squared minus 12a. And then I'm going to combine like terms. I'm going to write my answer up here. And I'm going to have 3a squared minus 7a plus 5. All over 5 times a minus 4. And nothing, I will go ahead and give you a heads up, nothing factors out of that one.
Okay.
So that is your final answer for that one.
All right.
And on number 16, I'm going to multiply the first one by a 3 at the top and the bottom. And then the second one, you'll multiply it by x minus 6 at the top and the bottom to get a common denominator. So you've got a common denominator of 3 times x minus 6. And then I'm going to distribute my 3 to both the 5x and the 3. So that's going to give me 15x plus 9 plus, and then distribute this 4 to the x minus 6. So that's going to give me 4x minus 24. Combine like terms. So it's going to be 15x plus 4x. So that's going to give me 19x. And then 9 minus 24 is going to give me a minus 15 all over 3 times x minus 6. And that's your final answer for that one. Nothing factors out of that one either. 19 is prime, so you really can't factor anything. And remember, this is just a solid term here.
Yeah.
So those are all the final answers for those.
Okay.
Does anybody else have any other questions, perhaps on some of the division ones or on the prior page?
I came in a little late, so I got I got from 10 on, but what I don't have yet is 5 through 9. Those 5 problems. Well, yeah.
Okay, so is there a particular one that you need some help on?
I needed help on number 8, actually.
Number 8. All right.
Yes.
Well, then I will definitely start there, and then maybe we can go back. Okay. Fair enough?
Yeah.
Okay, cool. All right. On this one, you want to, I'm going to go ahead. You want to rewrite this because it's division. It has to be rewritten. You keep the first, you change it to multiplication, and then you flip the second.
Yeah, KFC.
Oh, and when on this particular one, I'm going to go ahead and factor while I'm rewriting. So I can factor out a 2. So 2 plus 6, 2 times r plus 6. And then on the bottom here, I can factor out a 4. So that's going to be 4 times r minus 9. And then change that to a multiplication. And I'm going to flip it. So this becomes the top.
Yeah.
And so I'm going to factor while I'm flipping. And this is, well, I'm looking for 2 factors that multiply to give me a 90, a positive 90, that when I add them, give me a negative 19. And that's going to be negative 10 and negative 9. So I'll go ahead and write that in factored form at the top because I am flipping this to make my denominator my numerator. And then I've got r minus 10 on the bottom because I flipped this now. And now I'm going to look for those things that I can cancel out. And I know that I can cancel vertically or diagonally. So vertically, I've got r minus 10 over r minus 10. So those cancel. Diagonally, I've got r minus 9 and r minus 9.
So that would just be 2r plus 6. 2 times r plus 6 over 4?
Well, the 2 and the 4 actually reduce.
Yeah. Yeah.
That's going to be 1 and 2. So on the top, I have r plus 6. And then on the bottom, I have a 2.
Yeah.
And that's my final answer.
Yeah, that makes sense. All right. Can we do number 5?
Absolutely. We can do number 5. And then I can do number 9 if you want me. Do you want me to stick with division or do you want me to go back up?
Could I see number 9 with him?
Yeah, let's do number 9 real quick.
Okay. All right. I'm just going to go ahead and finish erasing 5 and then I'll get her. Then I'll be ready to redo her. Okay. 9?
Yes.
Okay. All right. So I'm going to go ahead while I'm rewriting. I'm going to factor out what I can. So I rewrite the first. And it looks like I can factor out a 10r at the top. And 10r into 10r squared is just going to leave an r. Plus, and then 10r into 60r is going to leave a 6. And then the denominator, I'm looking for what would give me a 36 multiplied when 2 factors give me a 36. And I can already see this is going to be a perfect square. But I'm going to write both terms out because that's going to be a 6 and a 6. Multiplied together, give me a 36. when added, give me a 6, or 12, I mean. So that's going to be r plus 6 and r plus 6. Perfect square. I'm going to change this to multiplication. And I'm going to factor the denominator while I'm rewriting. I can take a 6 out, and that's going to leave me r plus 6. And I'm going to factor my my numerator, but which is now my denominator, and that's going to leave me r plus 4. And now I can factor diagonally, and I can factor vertically. So vertically, I've got an r plus 6 here. Diagonally, I've got an r plus 6. And then these two 6s vertically cancel. So literally the only thing I have left is this 10r.
Wait, why did the
Right?
plus?
No, there's r plus 4 too. Sorry. What were you asking?
Oh, I was just gonna ask, did the r plus 4 go away? I was confused.
Miss Sparks lost her. But I found her eventually.
We're all losing it at this point. We're good.
Yeah. So it's r plus 4 and 10r.
Yeah.
Okay.
Yeah, that makes sense.
So there's your final answer.
Okay.
All
I
right.
think I'm good. Thank you, Miss Sparks.
You're welcome. Have a blessed afternoon.
You too. Bye.
Bye-bye.
And then I just need 5 and I'll be good as well.
Okay. Y'all are
Thank you,
doing
by the way.
great. Oh, no problem. I'm so proud of you guys. Everybody's doing so good, asking great questions. Really proud.
Thank you.
This is factoring with a vengeance.
Yeah.
Okay. This is multiplication. So really all we have to do is factor and see what we can cancel out. So on that top part, this factors as 6. And then when you factor the 6 out of the 6r minus 12, that's going to be 6 times r minus 2. And then down here, this factors as r minus 2, r minus 1, because -2, -1 are the two factors that multiply together to give me a +2 that when I combine them give me a -3. So now I'm going to look for things that I can eliminate vertically and those that I can eliminate diagonally. So obviously here you could either eliminate this diagonally or vertically. But you can only eliminate one of them. So if we cross this out vertically and we can cross this out diagonally, then that's going to leave me a 6 on the top and an r minus 1 on the bottom. And that's that's my final answer.
Awesome. Sweet. So I'm all squared away.
Okay.
Thank you.
Good job. Good job.
You have a
I'm
great
proud of
day.
y'all. Oh, you do the same.
Bye-bye.
Bye-bye. And I'm also going to roll down for the end of math lab and let you all have a minute to check your answers.